So finding the distance between 2 points. So there's a distance formula. But you can't just try to memorize the distance formula because it's kind of complicated and it's just straight from something you already know. So that's what's going to be better. So let's kind of think about this first. So we've got, I don't even need to use graph paper though. We've got this point 1 comma 3 and we've got this point 5 comma 6. And so the question is, we want to find this distance here. So just like what Chubb PhD says, that's a right triangle. So it's not like just this case we have a nice right triangle. We always have a right triangle here. And then we just have to look at the distance of the legs. So how do we get the distance of the legs? That's more of the question we want to look at here. Because we don't want to just do this for this problem. We want to think about what's always happening. So what is that x value there? Well, since that's just straight down from the 5, that x value is just 5. So then how do you get that length of the base? Well, it's, how do you get that distance? How do you get the distance between two things? You subtract them. So this distance right here is going from 5 to 1. So that distance is 4. And then, well, what is this y distance? Well, this height here at this point is 3, which means the height at that point is also 3. So if we're going from 3 up to 6, what's that distance? That's 6 minus 3. And so that's 3. And then this is what Chubb PhD was really saying. We have a nice right triangle. It's a 3, 4, 5 triangle. But if we didn't know that, we could, of course, set up 3 squared plus 4 squared equals the distance squared. And so 16 plus, or 9 plus 16 is the distance squared. So 25 is the distance squared. So yeah, we get d equals 5. And so that's the distance formula. That's the gist behind the distance formula. You've just got to, like, what did we really do here? So let's see. So if we were solving this for distance, see how, like, at the end we square rooted both sides? So let's start with the distance is the square root. But then what did we square root? How did we get these numbers? Well, we got this 3 here because we subtract these y values. We found the difference in height. And then, so that's the difference in the y values. Doesn't even really matter which one you do first, y1 minus y2. And then how did we get the 4? Well, we got the 4 by doing this difference in the x values. So that's just the difference in the x values, x1 minus x2. And that's how you get the distance between any point. So that's the distance formula. But really notice, it's important to notice that's just Pythagorean theorem. But what's also really cool about the distance formula is it works for any dimension. So if we were like in 3 dimensions, we wanted a 3-dimensional distance, you would do it exactly the same. But then you would just also do the z-coordinate. And just the more dimensions you have, just the more of those you'll do it. And that's how you do it. That's your distance formula. So you should remember it, but also when you come down to it, remember it just comes from the Pythagorean theorem. So it's not like you have to memorize it, you just kind of know it from Pythagorean theorem.